Hey everybody, how you doing? This is Adam Wysor again with the Fluke Corporation, and I am here at Test Equipment Depot. Today we're actually here to talk about the Fluke FEV100. This is our EV charging station tester adapter. So what we're going to do today is just kind of run through a couple of things. First and foremost, this tester is built and designed to test the safety and the functionality of electric vehicle charging stations. This tester is also compliant with the SAE standard, that's standard for North America for electric vehicle charging stations. It does a number of different tests that we're going to be able to run through a couple of examples today. One being a PE pretest. What that does is it actually will test for dangerous voltage levels in the earth prior to your actually testing the equipment itself. We can test the control pilot, which will actually simulate a vehicle connected to it. We can test for earth grounding. We can test for GFCI test. We can do voltage. We can do current. We can do waveforms, impedance and resistance, some of which can be done on the tester itself. Other tests do require another Fluke tool to do it, either a multimeter or an oscilloscope. I've got a Fluke 87.5 with me today so that we can run through a couple of those tests live. So it is designed to work with other Fluke tools, which is really nice. So what's in the kit? So we have a few different kits available. The one that I have here today comes with the test adapter. It comes with the type 1 connector. Now we do make other types of connectors depending on the type of station that you're testing. So there's, for example, Tesla has a unique connector. So we've got options for that. We also have kits that do include multimeters and oscilloscopes with it. And you also get a nice carrying case to carry all your gear. So next up, we're going to run through a couple of the individual tests, and I'm going to set that up right now. So I've connected, well, I've plugged in an actual residential style type 1 EV charger that I have here. So I'm just going to run through a couple of tests with the test adapter. So the first thing I'm going to do is I'm going to run a PE test, and the reason that we want to do this is we just want to confirm that there is no dangerous levels of voltage present on the ground connector. So what I'm going to do is I'm going to take my adapter, my type 1 adapter, and I'm just going to plug this directly in to the charger. So what we're doing here is we're actually simulating, or what we're going to do is we're going to simulate charging modes using the test adapter. So you'll notice on the front of the display there's a couple of different modes here. I've got A and I've got B. I've also got C and D. The difference between the C and D is whether or not there is ventilation required in that particular charging station. B mode basically means it's typically asking for payment information. So for the first test, what we're going to run is a protective earth or protective ground testing. So I've got this thing connected. I've got power. So the first thing I'm going to do is I'm just going to touch this PE pretest button. And what I'm looking for is a red light to illuminate. So if there was a red light illuminating here, I would know that there's dangerous voltage at the ground connector, and I would basically stop any further testing because there's obviously a ground fault. I would need to address that first and foremost before I did anything else. In this case, we're indoors. We're plugged into a regular 120 volt outlet, so there's no issues with grounding at this location. So we're good to proceed to the next test. So the next test that we're going to run is a GFCI test. So again, I've got my tester hooked up here, and what I'm going to do is I'm just going to jump to the C position. So again, B position means I'm asking for payment information if I was at an actual charging station. When I go to C, in this case, I'm going to the C mode, which is a non-ventilation required. You'll see the little fan icon is X'd out. So when I'm in C mode, I'm actually charging at this point. You'll see the green ready light has been illuminated, which means it's ready to go. And the red light is on down here, which means there's voltage present. So in order to do the GFCI test, fairly straightforward, I'm just going to hit the GFCI test button. And what it should do is it should terminate the charging cycle immediately, which it does. So basically what I've done is I've tripped the GFCI. I've tested to make sure that it stops the charging. Now, had I done this and it was either blinking before I tested it, or if it started blinking after I pushed this button, that would indicate that there was a fault voltage that was higher than 45 volts at the ground terminal. So again, this allows you to check and make sure that everything's properly connected. If this was blinking, I would want to check the grounding system before any further testing. The next test that we're going to run is finding out what the maximum charging current is on my EV station. So again, I'm going to connect my adapter to my station, and I'm going to then switch the charging state over to B and then to C to initiate the state that the charger is in. Now in this case, I'm going to use the output side of the tester, which is going to test the CP signal output. For this, I need to use the duty cycle mode on my meter. In this case, the 87.5 max that I'm using has duty cycle, so I'm just going to switch that over. Duty cycle is listed as a percentage. So what we're going to do is, now that this thing is in the charging mode, I'm going to connect my leads from the meter to the output side of the test adapter. So I'm going to connect my black to the ground and my red to the line. And what I should see is a number that's listed as a percentage. In this case, my meter is showing me 27.3%. So that's a percentage of on versus off. That's what the duty cycle is. And then using the percentage, the on-off duty cycle percentage, I can actually translate that into amps, just using a table. So what I know from reading my table is that 27% is roughly 16 and a half amps. So I will then know, while this station is charging, it's putting out roughly 16 amps. Depending on the station, it may change. Some of the commercial ones may output differently, but in this case, we know that the max charging amperage is 16 amps. That just about wraps it up for the FEV100. If you have any further questions about pricing or availability or some of the kit options, definitely reach out to Test Equipment Depot. My name's Adam Wysor with Fluke. Thanks for watching.